Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. This is going to be video 2A. It's going to be part of the Why series, and here we're going to talk about probably the most fundamental question is why do we need to get to net zero greenhouse gases? And this is going to be part one. It's also going to be part of the foundational series. So let's begin. So in this video, there are really two fundamental questions I'm going to try to address. The first one is why net zero greenhouse gas emissions? And you can probably guess from the title of this channel that I'm pretty passionate about the subject. I think it's a really important kind of question that we need to address. And hopefully we can do that in this video for you. And then the second thing I wanted to do at the same time was I have a lot of friends who, quite frankly, are climate deniers. And I get some feedback from them or questions from them or statements from them. And I also, since I've started this channel, I occasionally get some correspondence. And the kinds of questions I get really sort of fall into two categories. So I've listed them here as A and B. And A, I actually put quotes around because this is an actual excerpt from an email I received. And it says, there are very credible experts who are skeptical, and I believe an honest and open dialogue should be allowed to take place as science is never settled. And I would just say initially, yeah, I'm all in favor of an open and honest dialogue. And science is, of course, always changing. But the question I want to address, are there really credible experts who disagree with the basic science of climate change? So we'll talk about that. And then the other thing I hear frequently, well, yeah, the climate's always changing. And it's just part of a normal cycle. This is nothing unusual. It always happens, And so I'm going to do this in two parts. In part one, I'm going to focus on greenhouse gases and sort of how they operate. I'll show you the science of it, how it works. It's not going to be that hard. And then I'm also going to address at the same time question 2A. And then in part two, I'm going to focus on how greenhouse gases actually sort of impact Earth's temperatures. And answer question 2B. So let's begin. For this conversation, I thought I would bring my golf buddies along and let them participate. And so this would be the first question. You know, science is never settled. There are very credible experts who are skeptical about climate change, increasing temperatures, greenhouse gases, right? And my answer to them is basically no. I see no evidence, even from the critics that I've heard who are concerned, who are critical of climate change, don't think it's an urgent issue that we need to face. I've seen absolutely no disagreement on the fundamental science. So let me explain. So let's start here. So what do we know about Earth's atmosphere? Well, we know we sort of have 5 spheres, and it starts with the troposphere, and after that it's the stratosphere, etc. And if you take a look at the left-hand side of the slide, you can see the 5 spheres and some quick examples of what happens there. Now, we live fundamentally in the troposphere, and so I thought we'd just give you a couple key characteristics of the troposphere. Number one, as you go higher into the atmosphere, or into the altitude, temperatures decrease. The second thing is the troposphere has different heights. It's like 10 or 11 miles at the equator and 4 or 5 miles at the pole. And if you take a look at the pie chart, or the illustration, I should say, in the upper right-hand corner, where we have 0.3 Earth's atmospheric circulation, you look at the far upper right-hand side there, you'll see something called the Hadley cell, the Ferrel cell, and the polar cell. And you see how the Hadley cell is much higher than the polar cell. And that is sort of illustrative of what the troposphere looks like. Now, the other thing about the troposphere is that that's where all terrestrial life lives. That's where almost all of our weather occurs. If you also look at that atmospheric circulation one there, you'll see the trade winds, the westerlies, the horse latitude, the polar front, etc. All of that stuff occurs within the troposphere. And Earth's atmospheric circulation is really interesting. And I created a couple of videos that talk about that. You can see the thumbnail for one of them. And that really determines, for example, what our weather is like on Earth. So it is really those factors that determine where we have rainforests, where we have deserts, where we have thunderstorms, tornadoes, and things like that. Now, the other thing is, and so what's sort of the composition of the answer? Well, it's air. So what is air made of? It's basically 78% nitrogen, 21% oxygen, 0.9% argon, and 0.1% is greenhouse gases and the other things. So you see these greenhouse gases are just a minuscule part of our atmosphere. What else do we know? Okay, if you look at the pie chart in the upper right-hand corner, you'll see the composition of greenhouse gases. It's basically 76% carbon dioxide. The big three are methane at 16% and nitrous oxide at 6%. And then the other 2% are a number of other minor greenhouse gases. Now, if you go over to the top here and look at number 1, where we talk about primary greenhouse gases, I listed the 5 of them there, I should say. But I also want to show you the molecular structure of the greenhouse gases, because that turns out to be very important. And obviously, the molecular structure of each one of the greenhouse gases is different. Now, the other thing I want to point out, if you go to the illustration just to the right of that, where you see the word matter, you start with matter. Matter is really made up of molecules, right? Molecules like we talk about here for greenhouse gases. But within these molecules, there's a lot going on. Okay, there's atoms, there's electrons, there's nuclei, and then the nuclei within that has protons and neutrons. And then after that, it has quarks and ups and downs, etc. So the reason I'm showing you that, not that we need to get in, I tend to go into that in any detail, it's just to really make the point that inside these molecules is an incredibly dynamic kind of environment. So let's continue. So water vapor is a greenhouse gas. You noticed it wasn't in the chart, on the pie chart in the upper right-hand corner, and almost most of the illustrations and other kinds of things or calculations basically exclude water vapor. So why would they do that? Well, there's several reasons. One is highly variable between locations and seasons. Okay, so you have a monsoon season, then you have a dry season, etc. It's not directly affected by human behavior, and it has a low residence time in the atmosphere. So that's basically why they sort of exclude water vapor when they talk about greenhouse gases. But it is a greenhouse gas, and it does affect our temperatures. Now, technically, the atmosphere also has some other trace gases and some microscopic particles, which also can impact temperatures and, quite frankly, human health. But we're not going to discuss those here. So let's maybe stop at this point and say, okay, to my golf buddies, do you have any scientific disagreement with this? Have you heard, to everybody else, I'd say, have you heard any client in ours talking about the fact about these issues? Are they suggesting that the structure of Earth's atmosphere and the characteristics of the troposphere aren't true? Are they suggesting that the composition of air is something other than we're talking about here, basically? Is there any disagreement about what the greenhouse gases are and the percentages, like carbon dioxide being 78%? Have you heard anybody disagree about the molecular structure of greenhouse gases? I haven't. And have you also heard anybody disagree about the structure of molecules and how they operate? I mean, we're always learning more about it, but there's nobody out saying that quarks don't exist or that neutrons don't exist, or suggesting that this is not a very dynamic environment, right? Anyway, so as my clients, I will say, well, you're absolutely true. Yeah, I would agree with that. But there are credible experts who are very skeptical about climate science. It may not be the above items here, but there are other very important elements of climate science that you have not discussed yet. And I would say, okay, let's go. Let's take the next layer. So how is Earth heated? Well, Earth's warmed by the sun. And so the sunlight comes down as shortwave radiation. It hits the Earth, and then some of that bounces back directly into outer space. And then some of it, or most of it, probably gets absorbed into the Earth's surface, and then eventually gets radiated back into space, only now it goes back as heat or long-wave radiation. Well, why the difference in radiation? Well, first of all, the sun, its temperature is 5,000 degrees Celsius. So it's very hot, a lot of energy coming when the sunlight comes down. The Earth's temperature is about 15 degrees Celsius. So as we absorb that, and as it starts pushing it back, it comes back at a much longer wave related kind of radiation. Now, if we go to the next slide here, what happens is that, so when this radiant heat starts going back into the atmosphere, some of it interacts with greenhouse gases, some of it escapes and goes back into outer space. But why does some of it interact with the greenhouse gases? Well, it has to do with their molecular structure. And so when the greenhouse gases hit the long-wave radiation, they interact with one another. And that interaction process sort of causes some of it to get redirected back to Earth again. Now, that's a fairly complex subject, but it's really pretty easy to understand. But as opposed to me talking about it here, I've discovered really two just wonderful sources that explain this with illustrations, etc., and are very easy to understand. So I thought I would put them here. The first is, put the QR codes here, I should say. The first one is The Greenhouse Effect by Bozeman Science. It's a YouTube video. It's about, if I remember correctly, about 8 minutes long, and it fully illustrates exactly how this works. And then the second thing, I recently came across an article in Quanta magazine, and it's entitled The Quantum Mechanics of Greenhouse Gases. Again, it's an understandable article. It's not all that long, and has just some phenomenal illustrations there that show you exactly how this works. So in addition to having these QR codes here, I'll put that same information into the notes. But if you have any question about how this works, just take a few minutes out and look at those resources. I think you'll really find them informative. So that gets us to the next question again. Okay, is there any scientific disagreement with how sunlight hits Earth as shortwave radiation? I've seen nobody suggesting that that's not right. How about sunlight is reflected, some sunlight is reflected back to space as shortwave radiations, and it does not interact with greenhouse gases? Nobody is suggesting that that's not true. How about that some sunlight is absorbed into the Earth's surface and is radiated back into the troposphere as long-wave radiation? I've heard nobody who's a scientist climate scientists or anything else suggest that that isn't true. Okay. So how about how long-wave radiation interacts with the quantum mechanics of greenhouse gases? Nobody. Look at the illustrations and you'll see why. So for this set of things, the answer is, again, no. There is no credible scientist disagreeing with these fundamentals. But as my golf buddies would say, yeah, we know. But we know there are, some credible experts out there who are skeptical about climate science. And maybe not the above items, but there are clearly other elements of climate science that you've not yet discussed. Okay. Let me continue. It turns out that greenhouse gases are incredibly important for us. And the Earth just happens to be in the Goldilocks zone. We're actually, though, unfortunately, at the very upper end of that Goldilocks zone right now. But we're still within the Goldilocks zone. And so what does that mean? Well, if we didn't have greenhouse gases on Earth, the scientists are challenged the temperature of Earth would probably be 0 degrees Fahrenheit. And let me remind you, freezing is 32 degrees Fahrenheit, so it's a pretty cold place, and there probably would not be a lot of life on Earth. But fortunately, our temperature is, average temperature is 59 degrees Fahrenheit. Why is that? That's because we have the right amount of greenhouse gases in the atmosphere. But that number of 59 is getting dangerously close to starting to push us outside of the Goldilocks zone. So do we have any examples of what happens when you have too little or too much atmosphere? Well, we have them right next to our neighbors. So if you look at Venus, it has a very, very, very dense atmosphere. And the temperature on Venus is 867 degrees Fahrenheit. Look on the other side of us, we've got Mars. It has a very thin atmosphere. Now, during the daytime, it's kind of pleasant, 70 degrees Fahrenheit. But at nighttime, it's minus 225 degrees Fahrenheit. I mean, I don't think those are conditions we want to live in either, right? Or try to live in. So one other question we get. So when you say net zero greenhouse gases, what does that mean? We can't emit any greenhouse gases? And the answer, absolutely not. It has nothing to do necessarily with the amount of greenhouse gases being emitted into the atmosphere. What is absolutely essential, though, is that the additions of greenhouse gases equal the subtraction of greenhouse gases. It's not necessarily the absolute level that's going in. It's the net impact. So the additions need to equal the subtractions or what we're pulling out. And they're not right now by wide margins. So how do we remove greenhouse gases from the atmosphere? Well, there's really two primary ways this happens. There's photosynthesis, and then in the ocean it goes with photoplankton, and then Earth with living things like plants, animals, etc. And then you have diffusion, where it occurs on the surface of the ocean and on the surface of land and soil. Now, so when we have these greenhouse gases, they're stored. Where are they stored? Well, they're stored in plants and animals and me and you. They're in the soil, in the ocean surface, and photoplankton, in fossil fuels like coal, oil, gas, in sediments. And you can see from the illustration here on the left what all those cycles are. Well, how do we release them into the atmosphere? How do they get up there? Well, part of it's through respiration. Part of it is through decomposition, burning of fossil fuels, wildfires, volcanic eruptions, weathering, erosion, etc. So if you just take a little bit of time looking at the arrows and show you how this basically works. So this gets to the next question. Okay, do you agree with the climate scientists when they indicate that greenhouse gases are necessary for life on Earth. And it's really important is that we keep the greenhouse gas levels within the Goldilocks zone. I've heard nobody suggest that that isn't correct. And then, have you heard anybody, I mean, everybody I know agrees with the carbon cycle and how it operates. I haven't heard any climate science says this is nonsense, doesn't work like that at all. So where are we? And again, my climate science buddies, well, of course, nod their heads, say, yeah. But we know there are credible experts out there who are skeptical about climate science. You know, and there are a lot of them. But maybe, you know, we might want to look at if they have any conflicts of interest. Maybe not the above items, but there are important elements still out there of climate science that you have not yet discussed yet. And to that I say, okay, what's left? Exactly what elements of climate science that deal with how greenhouse gases work, etc., have we not talked about? What's left? Oh, you want a moment to think? Okay. And the response is, well, I can't think of anything right now. Okay. You know, but maybe the experts we're listening to never really talked about the underlying science. They may have talked about how windmills kill birds, or they may have talked about how electric vehicles aren't going to get us where we need to go, or other kinds of things. But nothing of that has anything to do with the fundamental underlying science of how greenhouse gases work. And so, okay, we get your point. But the Earth is always changing, right? And increase in greenhouse gases and temperature are just part of this normal cycle, right? Well, let me address that in part 2. So let me wrap this up. In this video, we talked about the major components of the issue. One is Earth's atmosphere. There are greenhouse gases. We identified what they are. We talked about the molecular structure. We talked about how the greenhouse effect, or how they work, how they interact with the sunlight and radiant heat from the Earth. We talked about the Goldilocks zone, and we talked about the carbon cycle. That's it, folks, in terms of the science associated with this. It's really that simple. And there is no widespread disagreement of scientists about these issues. So in part 2, we're going to cover the major components we're going to talk about there are temperature increasing. You know, we're going to link the link then with temperature increase with greenhouse gases. We're going to talk about the Milankovitch cycles. We're going to talk about GWP, or the greenhouse gas warming potential, and the atmospheric life of the various different greenhouse gases. They all have different potentials, and they have different atmospheric lives, and that's very important. So we'll talk about that. And we're going to talk about the bathtub effect. I want to mention that you can see the thumbnail for part B down there below, so please look at that. And I'd also urge you to also look at video 3, because here in that video, I'm going to talk about why now, why we need to take urgent action to get the net zero greenhouse gases now. Now, this video, as I'm looking at the clock here, this video is running very much longer than I wanted to again, and my apologies for that. So why don't we just wrap this up, and hopefully you'll be able to join us for video 2B and 3. Thank you very much for your time.